All right, everybody, thank you all for being here. This is a great turnout, but I'm not surprised. Dinosaurs are very fascinating. And we have kind of a dinosaur expert here. I'm not going to introduce him because he's going to do that himself. But thank you all for being here at this public lecture series. We have it every single month. Next month we will have the Master Gardeners of Cleveland County be doing a little panel. We have like 8 of them that are volunteers here, and they're going to talk about their experience in the gardens and here at the museum. So be on the lookout on our website for that. And without further ado, I'm going to let our speaker take it away.
Well, hello, everyone. My name is Kyle Davies. Oops. Let's try that again. My name is Kyle Davies. I work here at the Sam Noble Museum. Whoops. Come on. Oh, I see what's going on. There we go. As a fossil preparator, well, Sam Noble Museum, let's try it one more time. Come on, there we go. It's just not cooperating. There we go. As a fossil preparator, which is just a fancy way of saying it's my job to get the fossils cleaned out of the rocks and ready to be studied, displayed, or whatever we're going to do with them. And of course, as you I hope all already know, I'm here to give a talk on the dinosaurs of Oklahoma. Now, I hope you're not going to be disappointed. I'm just going to give a talk on dinosaurs in the strict sense, i.e., there's a tendency for a lot of people to use the term dinosaur as a synonym for prehistoric animal. But for people who in paleontology, dinosaurs is a very distinct group of animals. And I can't tell you how many sets of dinosaur toys I've seen where they'll include things like this good old Dimetrodon, which is not a dinosaur at all. Even some of the big animals that were alive at the time the dinosaurs were alive, such as the elasmosaur here, it's a type of plesiosaur, are not dinosaurs in the strict sense. So the question is, how do we differentiate what is going to be a dinosaur from other prehistoric animals that you might encounter? And the trick is, in doing paleontology, we're essentially doing a subset of biology where we're looking at animals that are related by traits they share in common. And so dinosaurs need to have a number of traits shared in common. One of the first ones is with early amniotes, which are some of the first animals come out and have eggs they could lay on land. They had this type of skull where you had the eye hole, the nose hole, but no other holes in the skull. And then one group developed a subset of holes, just one on the sides. They're called synapsids. We're actually synapsid. If you feel here when you clench teeth, you can feel the muscles bulge. And this lower bar here, whoops, now it's, come on. It's fighting me. If you look at this lower bar here below this opening, that's the rim of bone that you see that extends from your cheek back to your ears. There is another group of animals that develop 2 holes in the top of the skull, it's highlighted there in red, that are called diapsids. And in order to be a dinosaur, you have to be in the diapsid group. There are actually quite a number of other animals, as you can see by the list up there, that are in the diapsid group. But this is the kind of skull you have. Now the next thing the dinosaurs do, or this group that's evolving over time does, is they add an extra opening here in front of the nose. It starts off as a pit, sometimes it becomes a complete opening. It's called the antorbital fenestra, fancy word. But in order to be, the group that has that particular opening, they're archosaurs. So you have to be an archosaur in order to be a dinosaur. Finally, one of the things dinosaurs did is at this point in previous to this point in time, most of your animals had a sprawling gait, sort of like what lizards do. And dinosaurs brought the hind legs in under the body so they'd have more a sagittal gait. Allows them to move around potentially faster. The interesting twist is they only did it in the hind legs. They didn't do it immediately in the front, which means that our common ancestor for all the dinosaurs was a bipedal animal. And some of them go back to being four-footed later on in the evolutionary history of dinosaurs, but they all start off from a bipedal ancestor. Okay. So now that we've gone and gotten rid of the the critters that want to annoy dinosaurs, and we'll focus on the dinosaurs themselves. By the way, in this kind of classification, technically birds are dinosaurs. However, I'm going to limit my talk to non-avian dinosaurs, and because if I was trying to give a talk on Oklahoma birds, it would be for the birds. And so from now on, when I say dinosaur, I'm referring to just the non-avian dinosaurs, the non-bird ones. The first report of a dinosaur here in Oklahoma dates back to 1910 by an author named Larkin. It was all based on just one sort of beaten up bone, but it's enough to tell you that it's a dinosaur bone. It's a particular bone called the coracoid. Humans don't have those. But if you look at a dinosaur, that's where it is, right there at the head of the shoulder blade. So with that said, the main thing here in Oklahoma is we have three major units of rock that produce dinosaur bones. Up in the Panhandle, you have the Dockham Group, the Morrison Formation, and then down here in the southern part of the state, you have the Antlers Formation. Those are where our dinosaur specimens come from. Dinosaurs, of course, in the strict sense. Those three units of rock are actually fairly well spaced out in time, and they cover each of the three major time periods in what is the age of dinosaurs, otherwise known as the Mesozoic era. So you see the Dockham, Morrison, and there's the Antlers all lined up. So let's just start off with the bottom. The Dockham group. We actually don't have any fossil bones of dinosaurs from the Dockham, but there's its extent in Oklahoma. And what we primarily know for our Triassic dinosaurs is thanks to the residents in and around the little town of Kenton, which is out in about as far west in the Panhandle as you can go. In fact, in this picture, if you go out here, you're in New Mexico. That's how far out we are. But what we have are dinosaur tracks, so we're dealing with dinosaur traces. The first one, and the most common that we have, is this thing called Rallelagner. It's an ichnogenus, and from the shape and size of the tracks, its most likely producer was a little dinosaur called Coelophysis. And it's known from a lot of other places in the American Southwest, especially out of Arizona. So it's almost certain we had Coelophysis here in Oklahoma. We just don't have any of its bones, at least yet. Here's some pictures of the actual tracks taken out in the field. I can't tell you where these are from because they're on private property and they don't like trespassers. I don't want anybody getting the locals riled up or getting shot by the locals for trespassing. Another trackway they have out there, it's much rarer, is this one here. It's has the tremendous name of Pseudotetrasauropus, and it almost certainly was made by a type of dinosaur called a prosauropod. The interesting thing here is the silhouette is based on things like Ceratosaurus, which is known from Arizona. However, that's a Jurassic prosauropod. As far as I've been able to find in the literature, there are no known prosauropod dinosaurs from North America in the Triassic. We have them in the early Jurassic. Now they're known in the late Triassic from places like South Africa, South America, and Asia, but we have no bones yet from there. So it'd be really neat if our Dockham ever produced some nice prosauropod bones for us. And unfortunately, I don't have any direct pictures, so this is from an article describing our Oklahoma trackways of with the pseudo-tetrasauropus tracks would look like. And here we have a scene of what the area here in Oklahoma would probably look like back when the dinosaurs were roaming around in the Triassic. Note that most of the animals you see in this illustration, this is actually a mural out of the galleries. All of these are non-dinosaurs. They're prehistoric animals. The only one we have in the picture that's an actual dinosaur is, of course, the good old Coelophysis. So let's move up to the Morrison Formation. This is where we really can get into some of the meat of the story. This is the outcrop of that particular rock in the Panhandle. It was originally essentially identified as Morrison Formation and worked on by J.W. Stovall back in the 1930s. This is the discovery bone for that area out there. It was found in 1932 by a road crew improving one of the roads leading out to Kenton using an old horse-drawn grader. So in 1936, starting in 1936 and actually running into 1941, J.W. Stovall actually organized and ran a WPA project, which is a work progress administration organization to help relieve people in the Great Depression, where they dug up and collected these dinosaur bones. So we see it here. This is WPA Quarry 1. You can see they have nice modern trucks, old trucks, and here's our horse-drawn grader. So it was quite an operation. This actually alerted the people in Kenton to that the fact they had dinosaurs, so it's actually in the travel publicity for going out there into the Panhandle that they had this. This quarry is now currently marked with a large cast concrete femur above it. They would bring the bones back to a laboratory here in Norman where they got worked up. This is one of the WPA crews that were doing the work. A lot of them were just doing it for the money, so they weren't experienced. They were kind of rough with a few of the bones. But they did get things prepared, such as this giant thigh bone right here. This is from one of these huge dinosaurs that we can get. So let's look at some of the dinosaurs themselves. We have this gigantic meat eater that's known from the quarries. It's related to Allosaurus. In fact, some people believe it is actually just a giant version of Allosaurus. Picture of its skeleton. Was named Saurophagus maximus in 1995. And it's the type specimen. The bones here from Oklahoma are the type specimen for that name. And if you're not familiar with it in the sciences, a type specimen is the one which identifies the particular animal, and everybody then uses it for comparison when they think they might have found it someplace else. By the way, it also became the Oklahoma State fossil in 2000. Moving right along, we have indications. We have Diplodocus out there in the quarries. It's one of these animals that's referred to as a sauropod. It actually, Diplodocus is the namesake for a whole family of dinosaurs, the Diplodocines. Here's just some samples of bones of Diplodocus out of our collections. We also have Apatosaurus, which of course we all know gives us the gigantic mount we have in the gallery. Oh, by the way, that Saurophagonac's annoying it there at the side. And we actually have quite a variety of apatosaur bones in different size ranges, indicating we're dealing with growth series. So this is the tibia, or shin bone, from the gigantic one. This is a broken shin bone from a smaller one, smaller still, and this is from a juvenile right here. We actually have quite a number of juvenile bones, both of the Apatosaurus and another dinosaur I'll mention here in just a bit called Camarasaurus. And we use that to put together a mount of a juvenile Apatosaurus and add to our displays. We also have another, and these are Apatosaurus, Barosaurus, these are all the Diplodocids. So we now actually have indications. We've got the dinosaur Barosaurus out there, and here's some caudal vertebra from it. They come out of one of the quarries we're using for the explorology purposes. Now, I mentioned Camarasaurus. It actually belongs in a very different family of sauropods. They have more leaf-shaped teeth, where the Diplodocids have peg-shaped teeth. But we have good indications of it by the number of bones, including, as mentioned earlier, the juvenile bones. Also, we didn't know it for quite a while, but we have Brachiosaurus out there, which is a gigantic dinosaur. It was only identified about 1995, mainly based on this metacarpal here. One of the little bones, out of the palm. So that's, as big as that thing is, you notice that's in centimeters there. That's just a bone here out of the palm of the foot. Finally, we have a bipedal dinosaur called Camptosaurus. It's only represented by a few bones, such as this metatarsal here. But it's also the one, when you hear about Kenton, they talk about dinosaur tracks being out there. This is kind of faint, but you see there's a trackway here. And so when you go out and see the dinosaur trackways in Kenton, these are the ones you actually see, the probable Camposaurus trackways. We also have indications of Stegosaurus, not much, but those plates are fairly distinctive that you have on the back of the animal. And so there's an example of one of the Stegosaurus plates in our collection from the Kenton quarries. Finally, we have a few hints that we've got other things out there. This was studied by one of our graduate students. It's a small theropod that was out there. It might be a juvenile Allosaurus, but it doesn't quite fit. And here are the bones of it. So we're always hoping we might find more examples of this to get a better handle than we have. The Morrison is known for having a number of small meteors as well as the giant ones, such as Stoxosaurus, Solurus, other animals like that. So we have our hopes up that eventually we might actually find more about this animal, this particular type of animal. And here gives an example of what the environment in our Morrison of Oklahoma may have looked like. Floodplains, big sauropods running around on it, vegetation here and there. There's some indications it had dry spells, so it wasn't necessarily a super dense forest. So we'll move on finally to our last big formation, the Antlers formation there in things. Its outcrop belt is in south to southeastern Oklahoma. It's colored in green. These are actually sediments eroding off the ancestral ancestral Wichita Mountains and stuff. That's where the things, and the ocean that was at the time is actually up in North Texas. So you don't have to go much further south from Oklahoma to get your feet wet. It too was found, the specimens here were found by Stovall's work crews in the late 1930s. Although we've continued to work this is a picture of a crew working out here in the 1990s. A lot of the bones we've recovered out of the Antlers are actually found by a guard worked at the McLeod Correctional Center as a person who ran the dogs that would chase the prisoners trying to escape down, and he'd keep an eye out for dinosaur bones for us. So this is Bobby Cross. This is, again, a 1990s photo. One of the headaches, and oops, don't do that. One of the headaches for us is all this vegetation, and I'll get back to this in a bit. But this actually destroys bones. So it's having an erosional area like this that gives us our chance to pull out dinosaur bones. I'll mention him a bit more in the thing, but the bones that are being dug out right here belong to a dinosaur called Sauroposeidon. So let's just start looking at things. The first animal they found was actually a little dinosaur, or medium-sized dinosaur called Tyrannosaurus. It would, adult size would be about 1,500 pounds. And here's an example of a skeleton of one. We've actually got multiple remains of Tyrannosaurus out of the area down there that's very common. Another one that's very interesting is a giant meat eater. It's the largest meat eater known for its time period. It's here in North America at least, called Acrocanthosaurus atokensis, of course named after Atoka County. It's originally found based on a skeleton here in the 1940s. There's actually a number of skeletons, including this one, which wound up being collected by commercial collectors and sold to a museum in North Carolina. So when you hear about Acrocanthosaurus in North Carolina, it's actually an Oklahoma specimen out of McCurtain County. And I'm sorry, I should have said it. This also became the, well, I goofed it. This actually became the state dinosaur for Oklahoma. There we go. In 2006. So Oklahoma not only has a meat-eating dinosaur as its state fossil, we have a meat-eating dinosaur as its state dinosaur. Again, this forms the type specimen for Acrocanthosaurus. The one that a lot of people find most interesting is this gigantic dinosaur called Sauroposeidon. You can see our little meat eater here is not too happy trying to face one of those now. It's actually only known from about, oops. Sorry about this. It's actually only known from about 4 neck bones, but they're humongous. The longest of them is a little bit over 4 feet long. One of the nice things, though, for us is with the sauropod dinosaurs, the neck bones have a lot of morphology to them, and so they're very useful for identifying between different types of sauropods. It was named by a graduate student working here at University of Oklahoma back in the year 2000. So it's another type specimen here for Oklahoma. And the bones that we have actually have a strong resemblance to the dinosaur Brachiosaurus, which is known for much more complete skeletons. So the rest of the body is modeled on Brachiosaurus, enlarged. This gives you a feel for the scale differences. This is a 6-foot man. That's Brachiosaurus. That's Sauroposeidon if you scale it up to match. And that's what neck bones we have for Sauroposeidon. So it's technically a huge animal, and it's still listed in the Guinness Book of World Record as the animal, the tallest known dinosaur, because of the way it stands still. Now, when they were working on a Tyrannosaurus specimen, like this one here in the jacket, it's not too easy to see, but you've got things like, here's the manus being developed, or the hand bones. They accidentally ran across a few bones in the jacket that were not Tyrannosaurus, quite obviously. The sharpness and the points on those claws should give you a hint of it. Turns out they were a very nice match for another dinosaur already known from Montana called Deinonychus. It belongs into the dromaeosaur group, which are sometimes commonly referred to as raptors, even though that's not really the correct way to do it. So we actually have Deinonychus here, small predaceous dinosaur from the Antlers formation of Oklahoma. There are different views on how Deinonychus could look. The picture you saw first was an early version, but we now know that dromaeosaurs almost certainly could grow feathers, and so a number of artists are now adding feathers to their reconstructions of Deinonychus, giving you an animal much more like this rather than what you saw earlier. We're still working on a little bit of our Deinonychus finds, and so we keep hoping for a little bit more of it to come. We also have what I refer to as an indeterminate ankylosaur. We know that there is one of these armored type dinosaurs, which the silhouette indicates, but we actually don't know much more about it. But ankylosaurs have a distinctive shaped tooth, and we've gotten one of those out of one of our microsites down there in the Antlers Formation. So we know it's there, we just wish we knew more about it. Similarly, there's a small ornithischian dinosaur that's not Tyrannosaurus in the beds. It could be either a small basal ornithopod, as it says down here, a ceratopsian, a primitive one, sort of like either a psittacosaur or like our aqualops that we have in the displays, or it could be a pachycephalosaur. We just don't know, but there are the remains of the teeth, and it was described by some of our graduate students and one of our researchers here as they could tell it was a primitive sort of ornithischian tooth, but they couldn't really give much more about it, except they could tell what it wasn't. It's not Tyrannosaurus, it's not aqualops, and it's not Cogolosaurus, which is another potential, it's basal ornithopod. So we're still wondering, what in the heck do we have? It's just one of those questions we have to deal with. There's always the potential we have more teeth that have come out of these microsites. These are little tiny theropod teeth that may relate to other small meat-eating dinosaurs that were down there. We just don't know. But this is one of the things we always have to live with in paleontology. There's always a lot of things we just don't know, and feathering them out or getting a better understanding of them is just really going to require more finds. But this is from our mural out there in the gallery. This is what the Antlers Formation environment would have looked like with the Tyrannosaurs, the Deinonychus running around, and of course the great big huge Sauroposeidon. And one of our big hopes, and we keep looking for things, is that we'll eventually find more finds and get more information about the dinosaurs that inhabited Oklahoma at various times in the past. As mentioned earlier, one of our biggest headaches is getting areas where we can make these finds. This is the McLeod Correctional Center. This bare area right here is only bare because the Correctional Center was using it for training inmates on how to use heavy equipment. And so they stripped the soil layer off, got down to the actual rock of the terrain. Most of our state of Oklahoma is well vegetated. That's great for us, but it's absolutely miserable for the fossil bones because as they slowly move up, as erosion takes the ground level down, the roots come down and they actually destroy the bones before they ever get to the surface. So essentially, this is why most times when you see specials on going out and collecting dinosaurs, they take you out to desert regions where lots of rocks are exposed rather than into well-forested or heavily vegetated regions. May also be why they had a lot more luck finding fossil remains here in Oklahoma during the Dust Bowl area, simply because we were experiencing a fair bit of erosion at that time. And with that, I'd like to say that's what I have to say about dinosaurs for Oklahoma. We'll move from the living critters back to our fossils, but at this point, I'd be happy to entertain any questions you might have, and I'll do my best with it. So thank you for your attention, and that's it.
Does anybody have any questions for Kyle? Got one in the back.
Yes.
Hello, Dr. Kyle. Saurophyagnax was once considered a T-Rex specimen. Why is she now an Allosaurus?
Excuse me, say that again?
The Saurophyagnax was once considered T-Rex of that family, but now she's considered an Allosaurus.
The reason is from when I was young to now, they have changed a lot of what we know about dinosaurs. One of the most interesting ones to me was that it used to be believed that you had a group of large meat-eating dinosaurs that were evolving in sequence up, and with T-Rex being sort of the end of the line. and you had a small group of dinosaurs evolving that served the small meat-eating dinosaur niche. When they started taking closer looks at the specimens and the way their bones were arranged, they suddenly realized that that wasn't the correct story. What was happening is those small meat-eating dinosaurs were evolving rapidly, and every so often they would throw off a big meat eater. So they would get large, and it turns out the T-Rex shape seems to be the ideal shape if you're going to be a gigantic meat-eating dinosaur. So we now know a lot of the big meat eaters are not related closely to each other at all. They're related to these smaller things.
Thank you.
And so at the time Saurophagonex is alive there in the Jurassic,
Yeah.
there is already a small meat eater, Stochosaurus, that is in the lineage that's going to lead to Tyrannosaurus Rex. Okay, any other questions? Yes?
Has Sauroposeidon been found anywhere else?
It has been suggested to have been found in other places, but not confirmed. It was suggested that for a while that some bones of sauropod dinosaurs found up in Montana from the same time period were Sauroposeidon, but the problem is we're not certain, and there's no overlap between those specimens to confirm that. Because what you're going to have to do to get a confirmation that you've got Sauroposeidon is you've got to find those same bones in the neck to be able to do a comparison against them. The other headache, it used to be assumed, and this was done back in the past, that you could only have an environment that could only support one gigantic animal like that in a given area. It's sort of like, if you look at the modern world where you have elephants, you either have Indian elephants or you have African elephants, but you don't mix them up. Yet as we find in the Morrison there, look at how many different sauropods we have, all living together at the same time quite happily. It's one of the big puzzles in paleontology is how did they split up the niches in the environment to do that? So the fact that you've got a big sauropod up there in Montana doesn't mean it has to be the same sauropod. In fact, they actually have another big sauropod coming out of Texas at the exact same Trinity group that the Antlers Formation belongs to, called Paleontology. Some people have synonymized it with Sauroposeidon, but we have a researcher who's working on this right now who basically says, no way, they're not the same animal. There actually are two big sauropods running around at that time period. We just don't have them in Oklahoma, we have them down in Texas, but there's a very good chance that we might find them eventually up here in Oklahoma. So that's why I said, there's always this room for future finds. Yes?
Have there been any velociraptor finds in Oklahoma?
No, but remember that the Deinonychus that I showed there is actually a relative to the Velociraptor. Velociraptor, by the way, is an Asian animal that's found over there in Mongolia. And it's actually, this may sound strange, Deinonychus is a larger animal than Velociraptor. So it's...
The kids confuse them from the movies.
They do. Well, part of it is the movies actually show an animal that's actually closer in size to a critter found in Utah called Utah raptor. Because Velociraptor would be about that tall at the hips. No.
That's not very cool for the movies.
Well, that was the thing is, they actually, one of the original plans based on the novel was they would have Velociraptor would attack you in groups like piranhas.
Oh.
And that would make, you'd have these little tiny things and you go, oh, they're just little tiny things. And then they would swarm you.
Mm-hmm.
But the special effects department said, we can't afford to do that. So they made them larger so they'd be more a menace. Now they could have taken care of that. Utah raptor was just being discovered at that time. So they could have taken that by just simply saying, we've got this Velociraptor-like animal, but it's much larger that we just discovered by accident in doing our DNA analysis, and left it more nebulous that way, but you know how movie makers are. Yes?
We have the state fossil on display. Do we have the state dinosaur on display? I forgot the name of it.
The Acrocanthosaurus.
Yeah.
Unfortunately, no, we don't. We had a small sample of it but we don't really have one on display. There's a lot of complications in that story, and I'd rather not deal with them here and now. Forgive me.
Sounds good. Sounds good. I was just wondering for.
Yeah.
Well, how accurate is the replica of the Acrocanthosaurus down in Broken Bow?
It's actually it's cast from the bones that were sent to North Carolina, so it's fairly accurate. The only flaw is some of the bones that belong to that individual were in our collection, and they didn't manage to mold and cast those to put into the reconstruction. So it could actually be a slightly better reconstruction if they could include those. And that's one of those complications that I don't want to really get into right now.
Yeah. I'll ask them.
Yes.
What about the broken shin bone? Where'd you find that at?
The broken,
The Tyrannosaurus or the shin bone? Fossil?
the fossil shin bone.
Yeah, the one that's in the gallery,
Yeah,
the femur.
The leg bone, I think.
Oh, the big tall leg bone that's on the up against the wall. That's out of the Kenton quarries.
Yeah.
There in the Morrison. So that's where it was found. So it's out of the far Oklahoma Panhandle. I'd have to look it up. I think it's from WPA Quarry 1, but it may be from one of the others. There's quite a number of they opened actually quite a number of quarries. One of the things that they did and with the WPA is you had to hire locals to do your work in any given area. You couldn't bring in workers. And so that, by opening the quarries up there, Stovall actually provided work for the people living in Cimarron County. One of the things that resulted from that is in order to keep the project going, the locals learned to hunt for fossils and actually identified additional quarry spots for Stovall. The whole thing got shut down with the start of World War II. Yes?
What's your favorite dinosaur?
Well, I always tell people my favorite thing is actually diversity. I like to see a lot of different things. But if I have to pick one, of course, it's the Ankylosaurus. And I know some people pronounce it Ankylosaurus, but I actually talked to a classics major, someone who studied the ancient Greek and Latin, and he said, no, it definitely is pronounced Ankylosaurus, not if you're going to follow the Latin.
Yes.
I say that cautiously because one of the other basic rules that I learned long ago in paleontology is there is no correct pronunciation for scientific names. There's only a correct spelling. You always got to spell them correctly. One of the reasons they did that is because different European languages transliterate the old Roman alphabet in different ways. So what we call Tyrannosaurus rex in some European countries is Tyrannosaurus rex. Because it's derived from the same word as tyranny. Yes?
What percentage of the state fossil is actual bones and the other part is reconstruction cast?
Probably based on bone count, about 15-20%. But we're also having to associate bones because it was found in a quarry situation where you actually had two individuals in there that are almost identical in size and shape to each other. So that's the headache there. In terms of volume, though, you'd probably get a higher percentage because at that time, when they were collecting, they weren't that good about collecting the smaller bones. And so a lot of your count of the bone count in dinosaurs is the numerous tail bones you have, things like ribs, where they focus more on getting the big leg bones and other stuff like that.
And, sorry again, what is the most complete fossil that you know of in terms of percentage of real bones?
There are several where they pretty much have the whole animal. Actually, a classic example of that that they show is Archaeopteryx, where they got preserved in the bottom mud of a lagoon. They peeled it off, and pretty much all the bones of the animal are there. So you get the 100% level there. We actually, here in Oklahoma, one of their Tyrannosaur finds, and we refer to it as the good Tyrannosaur, we got a majority of the skeleton, and we lost a section of tail that had to erosion, but we have everything from the skull and even the tip of the tail, but except for that one segment that got weathered away. So it's and it actually shows some interesting bones that you normally don't even see in a lot of specimens, such as, you have bones that support your your throat here. It actually has the hyoid bones from Tyrannosaurus.
Interesting.
Yes,
I
back there.
suppose that the Coelophysis got preserved with its last meal in its stomach.
The Coelophysis they have, and there's people debate that back and forth whether it really is its last meal or not. But it's from a mass death assemblage. So essentially, something killed basically a group of Coelophysis all at pretty much the same time. And so it's just a matter of luck in that particular case. And a lot of our more interesting fossil finds are really just a matter of luck. Or what was a bad day for the animal.